ADS-B is a Mode S transponder-based surveillance technique that relies upon aircraft or airport vehicles broadcasting their identity, position, and other information derived from onboard systems such as GNSS receivers or altimeters. The signal can be captured for surveillance purposes on the ground, that's referred to as ADS-B out, or onboard other aircraft, referred to as ADS-B in. The latter can facilitate airborne ground situational awareness to aid spacing and separation of aircraft. The A within ADS-B stands for automatic, because unlike previous transponder technologies like Mode A or Mode C, no external stimulus or interrogation is required for an ADS-B transponder to transmit its signals out. These unsolicited downlink transmissions from an ADS-B Mode S transponder are referred to as squitter. The D in ADS-B stands for dependent, because it relies upon onboard systems to provide surveillance information, the S in ADS-B, to other parties. Finally, the B in ADS-B refers to the fact that the data is broadcast, i.e. the source transponder itself has no knowledge of who receives the data and there is no interrogation or two-way contract between it and the receiving device. ADS-B is seen as a key enabler of the future of air traffic management networks, contributing to the achievement of the Single European Sky performance objectives, including safety, capacity, efficiency, and environmental sustainability. So what do we mean by greater efficiency from an ADS-B transponder? So efficiency savings can be achieved both on the ground and in the air for aircraft that are equipped with ADS-B transponders. At airports, a locally optimized mix of available technologies, i.e. airport multilateration, surface movement radars, and ADS-B out will enable advanced guidance and control for optimized aircraft spacing that can be part of an integrated airport operation. In the sky, if an aircraft is equipped with ADS-B in and a means to effectively display available surrounding traffic information to the pilot, then airborne self-separation can be optimized and pilots can have better situational awareness. In terms of increased safety, the enhanced level of shared data that ADS-B enables allows pilots to more accurately assess the position of other aircraft and receive real-time warnings or redirection. This creates a significantly improved safety profile with call-outs no longer subject to latency constraints and error levels are minimized. ADS-B can also monitor air traffic at very low altitudes or on the ground, so inadvertent runway incursions become appreciably less likely. There's also the ability to provide advanced information. So in addition to real-time weather reporting, ADS-B also provides other supplementary information for pilots, such as runway closures, flight restrictions, and terrain maps for low visibility areas, all of which further augment the safety and efficiency of ADS-B-enabled aircraft. As I mentioned earlier, ADS-B is a Mode S transponder-based surveillance technique, and the table here shows how Mode S transponder functionality has changed over the years. It has gone from being a basic interrogator-based system reporting things such as altitude and aircraft codes to an automatic broadcast system which allows much more information to be reported to the ground and shared within the sky. Now, ADS-B has existed as a technology for many years, as many of you will know, and as you probably know, it's used within Europe and around the world. It's in use within Europe and around the world already. Now, different regions and countries have mandated the use of ADS-B transponders on aircraft flying within their airspace at different dates throughout the last few years, and the table here shows the status of each of these. You will see that within Europe, the deadline for implementation of ADS-B within specified aircraft is now the 7th of December 2020, a recent change to the original date, which was the 7th of June 2020.